In the last 4 segments, we discussed the conceptual issues involved with pure torsion. And in this segment, what I'll do is I'll talk about some standard problems which you will always see in all the books which you will. In fact, why would I call in books? In fact, anywhere in engineering application where you have a situation of torsion, one of these kind of problems will be there. Means you should always try to correlate your actual problem in the field to one of these problems which I am going to now talk about. And obviously from exam perspective also, this is important in the sense that most of the time you will get one of such configurations which you should be aware of. Like in the axial case, if you remember, we studied about very similar cases. The same situation we will do. In fact, I'll draw an analogy between the axial loading case and then this, okay, so that the idea will be clear. So one is okay, I'll start with say even the canonical configuration. So this side I'll do for the axial loading, okay. So this is for axial loading, and so if I go that side, it is for the torsional case, and I'll draw say like this. So this is the canonical configuration through which you should represent the torsional case versus the axial case. Now we had the case of multiple loading, right? So suppose here F1, say here F2, here F3, and here F4. So that's a case of importance which you should know how to solve them, okay. In fact, let me put in this way. Here the similar case is again like this. You have torque T1, say torque T2, say T3 and T4. See, this whole thing is under these conditions, okay. Now multiple loading cases, but then there could be another case like here with stepped so I'll do something like that, stepped shaft case or a rod case in that condition, and on that you can have say F1, say F2, F3 and F4. So such things, and then there I can even include the other case. Actually I could have included this also here, but I had drawn it initially, so I just split it. So in this case, this could be of different material and this could be of different material, okay. So that means now I am talking about the splitting into different free body diagrams, if you remember. So wherever you have a force, material or area discontinuity, you have to split them, okay. So that concept will be used in such a case, and exactly the same conditions can happen here. You can have a case like this. Okay, I'm drawing anyway the 2D only. So okay, and now you can have your torques anywhere like that, okay. So sorry, so T1, T2, T3 and say T4. So these are the kinds of situation. Again here the same concept, wherever you see material, area of force, torque discontinuity in this case, you have to split the whole thing at those many sections or segments, and then consider the free body diagram of each to convert them into the canonical problem. The idea of splitting is because you know everything for these conditions. So your problem has to be split into smaller or simpler problems which looks exactly like this or this in the case, okay, depending on the case. So that's the thing, and then you will see problems like one major configuration is the statically indeterminate problem. Okay, and then you have say forces here. Okay. The thermal stresses and all, I'm not putting them into this segment or configuration list because that's a reason of the stress being developed. Okay, so that there could be many such cases, so or reasons, so I'm not putting them here. I'm just talking about broader configuration types depending on the boundary conditions and the geometry and the loading condition. And similarly here you can also have in fact I could have done this here. Okay, I'll do this. So here maybe this side the area also is different, okay, and the material also is different. You could have this. I have just summed them up along with the statically indeterminate condition. So in this case again I would try to do that. So up to this point say it's solid, and from here it's say hollow, and in this case again you have the condition of statically indeterminate, and then you have your loadings which could be here say T1, maybe here and here say T2 and T3. So like that. So the condition, so the major change from here to here is the conditions of statically indeterminacy, where you have to use the angle of twists conditions to write an additional equation so that the lack of adequate number of equations will not be felt. Okay. Anything else which I can see here? Okay. I don't have much space here. Okay, let me go to the next page. Say, so in the say in such conditions you could solve this, right? In the maybe here also, who cares? So continuous variation of area or force, whatever it could be. So that's the idea. So continuous variation of either area or material or force. So that belongs to this situation. And the same thing I can draw here, that now here I am not again putting this under a separate case where you have the extension under self loading, because in that case the force is changing very continuously. So it is just a reason, the self load is a reason by which your force is varying continuously. There could be many reasons or any reason. So I don't care about that. I am just putting that as a special case where your force, material or area is changing continuously. In this case again the same thing, that your area could be changing or your torques could be changing. There could be very rare cases where the torques will change continuously. That can happen if some friction force is acting, which is changing across, either because the normal reaction is changing continuously or the coefficient of friction is changing continuously. So, such cases can arise where the torque can change continuously, or maybe just the area is changing continuously, or the material property may be changing continuously. So, such cases can be considered. So, T1, T2 and maybe T3. And the idea here in any such case is split them into infinitesimal lengths so that you can consider all those things which are varying, or any of those things which is varying, to be constant over that infinitesimal segment, so that you can consider that small portion to be of these type. So, that is the basic idea under which you can solve them. And then one more type of problems which can come is something like this. Maybe, sorry, I am using green color. Maybe, sorry, say suppose there is like this, and say you have connected this to a rigid body here. This is a rigid one, okay, and then you have, say, another body here, another body here, which are flexible. This is a rigid one. Okay, let me even hatch this, and then maybe these are like that. Okay, one more thing I should do here to make this one dimensional axial loading condition, so that these can move only parallel. This rigid one can move only parallelly, okay, and then you can have a condition like this, say suppose, and then you can have load anywhere, maybe here F1 and maybe here F2, maybe here F3, like that. Okay, so this is a kind of problem which you can come across. And similarly, in fact, I could have included more conditions to here. Anyways, so you know what I mean, okay. And then here, maybe cases like this, say suppose a shaft is like this, and you have a gear connected to this. Okay, so I just have to erase these things. Okay, and similarly there is another shaft. Okay, now another shaft which may be of this length, of different dia could be, and then you have another gear which is connected here maybe, and again I should erase this to make it clear. Okay, and then should I show them like they are, you know, sort of okay, and they are like gears maybe, okay, not only because friction, they are actually mated at the mating surface and they are driving each other. okay, or one is driver, the other one is a driven gear. And then you can have different types of say maybe this side it is completely fixed, but this side you can have maybe, you know, a bearing on which it's is resting like that. And similarly here maybe it's again resting on the bearings like that, and it's free to rotate, but then yeah, so it's like this. And now maybe you are applying torque here, who knows, okay. I'm just giving an example. So in such cases, how to get the deflection, total deflection, then maybe stresses in the shafts, in the gears or whatever. So problems can be, then I'm just talking about the configuration, then after that the problem can ask many things based on that. In fact, a Moore circle problem can come from here if you consider, you know, an element here maybe, and the state of stress of that particular element could be asked for a discussion on the state of stress using the Moore circle. So now, so these are some of the very important, very widely seen configurations. So please be aware of all such things, and so these are the first phase, and these are some second one. If something else comes to my mind, then I'll add it as a separate segment. But now these are the things, these are the configurations which are coming to my mind regularly. In fact, once we go to bending, very similar cases, again we will see that under the case of bending also such situations or such configurations needs to be analyzed, or at least you should have practice of solving such configurations, so that any problem either in the field or in the exam you won't face any difficulty. Yep, I think that should be the end of this segment. So see you in the next segments.